Key features of graphs. Explain why the graph shown is the graph of a continuous function. Well, a continuous function is something that doesn't have any breaks or gaps in the line, and that's why this graph is the graph of a continuous function. Because if you look in there at the line itself, there are no breaks or gaps, sorry. So this is the explanation for that. Let me make this a little bit smaller. There are no breaks or gaps in the line. That's why it's continuous, because there are no breaks or gaps in the line. Okay, the next one. Answer the questions below for the following graph. What is the absolute maximum? Well, absolute maximum is the highest point. So if you go to the highest point on the graph, because this is a maximum too, but it's not the highest. Absolute maximum is the highest. You go to the graph and you go and see where you're at on the x-axis. So that is 50. And then you go and see where you're at on the y-axis, and that is 400. So as a point, the absolute maximum is 50, 400. If you want the value of the absolute maximum, that's the y value. So it would be 400. Use set notation to write the domain and range of the function. So it's talking about this function in the graph. Domain and range, if you think of your XY table, domain and range is like going to the doctor. So the domain is the x-axis. So the domain, for set notation, you have to have brackets. You have to tell that domain is x, and that means such that. That's just your defining x. So if you look on the x-axis of the graph, it goes between 0 and 60. So you write that like this. X is between and includes 0 and 60. That's the domain. The range is the y-axis. Set notation would have y such that. Now if you look on the y-axis is from 0, and then the graph we already talked about, the maximum being 400. So the range is between 0 and 400, and it includes 0 and 400. So you would say range is y between 0 and 400, and that would be the range. Okay, the next one. Another balloon had the same height as the second balloon for the first 50 minutes, but then took 5 minutes longer to descend. How did the domain and range for the second balloon compare to the domain and range in the previous question? Well, the domain for the second balloon is, okay, in set notation, it would be x such that instead of 60, it's going to take, because let's look over here at the graph a minute. See, minutes. So since it took 5 minutes longer, it's going to be between 0 and 65. Because it's 5 additional minutes, 5 minutes longer that it took to descend. And because the ride lasted 65 minutes instead of 60. The ranges are the same. The ranges are the same because Neither balloon went higher than the other. It doesn't say anything about one balloon C. It says same height. So since the height is on the y-axis and it's the same height, the ranges are going to stay the same. They're not changing. The only thing that's changing is the domain. Okay, identify the y-intercept. Y-intercept is where the graph crosses the y-axis. So if you look back at the graph again, it's crossing the y-axis right here at 0. This is the y-axis. It's crossing the y-axis at 0. So that's the y-intercept is 0, 0. And what does it represent in this situation? The y-intercept is always the initial or the starting value. So it represents the height at the start of the ride. Okay, would it be possible for the graph of another balloon's height to have a different y-intercept, and explain? No, because they're all starting from the ground with the height of 0. They all start on the ground. And the height would be 0 on the ground.